Hello, I'm going to try to explain everything you need to know about the Smith charts in the shortest possible time. Now these four are the basics of Smith charts: plotting load impedance, load admittance, the VSWR circle, and the reflection coefficient. The first example we are considering is load impedance 50 plus 100 j omega and the characteristic impedance 40 ohms. Now we need the normalized impedance before we can go ahead and plot the load impedance. The normalized impedance is going to be load impedance divided by characteristic impedance, which for this case is going to give to us 50 plus 100 j omega by 40 ohms. So that's going to be 1.25 plus 2.5 j omega. Now we have to plot the 1.25 plus 2.5 j omegas in the Smith chart. So this is the Smith chart, and this horizontal line is where you are going to plot the real part of the load impedance, and you will be looking at this outer part of the Smith chart to plot the imaginary part of the load impedance. Now come on, this is 1, so we need 1.25, which would be here. I have marked it previously for convenience, and this is the line we are going to move, and we need 2.5, which is again I have marked it here. So as we can see, 2.5 would come this way and 1.25 would be coming this way, and they would be meeting at a point like this. This point is going to be the load impedance, and you have plotted the load impedance. Now to draw the VSWR circle, the radius for your compass is going to be from the center point 1 here and to the plotted load impedance. Once we have drawn the VSWR circle, plotting load impedance is very easy. You just take a ruler and a pencil, and from the load impedance draw a line straight through the center point, this one, and go and touch the circle on the other end. That point is going to be your load admittance. Now we have plotted the load admittance here, and to find the reflection coefficient, there are a lot of ways in the Smith chart, but the easiest way is to make use of these scales in the Smith chart. Now as you can see, it can give us the SWR, the return loss in dB, the reflection coefficient, and this side it can give us the attenuation and transmission coefficient and a couple of other things. So this is really easy. All you have to do is you have to take the radius of this VSWR circle and go here to the scales and figure out which parameter you want. Supposing you want the reflection coefficient, which is here, just keep this thing at this, keep the compass at the center and cut an arc, and this point where it touches is your reflection coefficient. To sum up, plotting load impedance, divide your load impedance by your characteristic impedance, that is going to be a normalized impedance. Go ahead and plot it in the Smith chart. This line is going to be your real part, and for the imaginary part, look towards this part of the Smith chart, and once you have marked it, you have to draw the VSWR circle, which is a circle with this as the center and this point as the radius, and wherever the circle touches the real part, that's going to be your VSWR value. And for plotting load admittance, take a ruler and go across the center towards the other part of the Smith chart, and that's going to be a load admittance. And for reflection coefficient, the easiest way is just going ahead to this part of the Smith chart, same radius as the VSWR circle, this as the center, and cut an arc, and where it touches the scale is the value for that parameter, and this works for all these parameters and all these parameters. Thank you.